Okay, so one of the types of plate boundary that you might be asked about is a transform plate boundary or conservative plate boundary, and much in the same way as the others, you'll perhaps be asked either to explain how the process works, or to be asked whether you get volcanoes or earthquakes at these boundaries. Now, this is at this boundary, as it says with the top tip. If you come and have a look over on the side, you don't tend to get volcanoes here, because remember, volcanoes are only going to occur if the magma can be released from sort of underneath the plates, and actually the plates here are locked together tightly, and that's going to create the earthquake we're going to talk about in a moment. And at that point, that means that the magma can't be released because there's actually no gap for it. So we've got a diagram here. As always, make sure you draw the diagram if you can, even if it doesn't ask for it. These are usually done as a kind of bird's eye view, sort of aerial sort of image, just because it's easier to show the plate sliding past each other. Now, in this diagram, I've shown that the plates are moving in different directions. In fact, you could, in theory, have, let's say, the plate on the right here moving in this direction as well. But if it's moving at a different speed to this one over here, which I've just starred, then that pressure can still build up. So the plates can either be sliding in opposite directions or actually in the same direction but at different speeds. So let's have a look what we might write. So convection currents, as always, we know they're that kind of driving force. They cause the two plates to slide past each other. However, as the plates are locked together, pressure builds up. Very similar to when we talked about the destructive plate boundaries. That kind of pressure builds up because whilst this line that I've drawn looks kind of straight, that's actually kind of an irregular line where rocks are actually locking into each other and don't necessarily nicely want to slide past each other, so they can't. The easiest way to do this quickly, if you're watching the video, is if you kind of slide your fingers together from your left hand and your right hand and then try and move them sideways. It's difficult to do because they're locked in, and that's essentially what happens with the rocks. So pressure starts to build up. And then when the pressure becomes too great, and what we mean by too great is really perhaps a large sort of rock or section of the rock shatters, breaks, you get this kind of jolting, the energy's released, and that's the earthquake, that kind of jolt sort of alongside each other. No volcanoes formed as there's no space for the magma to be released, which we've talked about. There's no subduction, which we talk about in one of the other videos. So there's none of that process going on. So we don't need to worry about sort of volcanoes. And you can see the center point that I've labelled on here, which might be worth actually noting if you talk about this in an exam question, is you've got the epicenter. Okay, so the epicenter is the point on top of the land where the earthquakes actually sort of occurred. It's the strongest part. It's quite often the point above where the rock has cracked. Remember, further down in the ground, that's called the focus. Okay, so that's the actual point. And what we can say is that if you wanted to even take that further, that the more shallow that the focus is, and that often makes the sort of the impact of the volcano, the earthquake, larger. So if I just quickly draw a diagram for that. So if you've got a building on the top and we've got a focus here, this point here is going to be the epicenter, because it's the point directly above the focus. Now if we have the same strength earthquake, but we have another one, make that one red, just highlight. If the focus is a lot closer to the surface, okay, so this is underground. Okay, on the one in red here that we've got, I'm just underlining there, that the impact of on the epicenter, if they have the same size earthquake, is usually bigger, because actually if you think about it, that's releasing energy waves. You will have drawn a diagram where basically you've got kind of energy waves actually coming out from the focus, and obviously the closer that is to the epicenter, the stronger it's likely to be.